Hello, student. This time I will talk about the aggregates of concrete. It is well known from the last topic that aggregates are one of the main materials to produce concrete in addition to the cement. Moreover, aggregates has more volume than the cement paste, about 3 times. Okay, so aggregates is very important and must be carefully considered. In this section, the outline is consists of the first topic is why the aggregates are used in concrete. Next is classification of aggregates. And the last topic is basic properties of aggregates and its effect on concrete properties. Why the aggregates are used in the concrete. The aggregates generally occupy 70 to 75% of the concrete volume and strongly influence on the properties of fresh and hardened concrete, such as workability, strength, and durability, as well as structural performance of concrete. Generally, concrete aggregates are divided into 2 portions. The first one is coarse aggregate, which often use crushed limestone, while that of sand is often used as fine aggregate. There are 3 main objectives to use aggregate in concrete. The first one is to provide the mass particles, which are suitable to resist the loads. This means that strength of aggregates is typically higher than the cement paste. In addition, aggregate has more volume stability and, and better durability than the cement paste. The second is to reduce the cost of the concrete because of aggregates, which are sand and rock, are much cheaper than cement. The last one is to reduce volume changes of concrete due to the setting and hardening process and from moisture changes during drying because of aggregates are viewed as an inert material. Classification of aggregate. Aggregate used in concrete can be classified into 3 types depending the following criteria. The first one is according to sources of aggregates, which are natural and artificial aggregates. The second is according to the unit weight of aggregate. These criteria dive into 3 levels that are heavyweight, normal weight, and lightweight aggregate. And the last one is according the size aggregates, which is typically criteria used in concrete work and classify aggregates as coarse aggregate and fine aggregate. According to the sources of aggregate, aggregates are divided into 2 types, which are natural aggregates and artificial aggregate. The good example of natural aggregate are river sand and rock or gravel. For artificial aggregate, it is mostly a byproduct obtained from special manufacturing process such as blast furnace, slag, and expanded clay. According to unit weight, aggregates are classified as 3 levels, which are heavyweight, normal weight, and lightweight aggregate. The heavyweight aggregate is the aggregate having the density more than 40 kilograms per cubic meters. For normal weight aggregate, which is widely used in many types of concrete, it has density range from 400 to 30 kilograms per cubic meters. And the lightweight aggregate has density between 300 to 100 kilograms per cubic meters. According to the size of aggregate, coarse and fine aggregates are classified by using a sieve number 4, having the opening size of 75 millimeters. This picture shows the definition of the number of sieve. The sieve number denotes the number of holes present in the sieve within 1 square inch. For example, sieve number 4 has 16 openings within 1 square inch, 1 inch in X and Y directions are dived into 4 openings. So the total is 16 openings within 1 square inch. In the same way, sieve number 8 has 64 openings. The coarse aggregate is the aggregate having the size larger than 4.75 millimeters or retained on the sieve number 4, while that of the fine aggregate has the size to be smaller than 4.75 millimeters or passing this sieve. In some case, very small rock which is past this sieve, it is classified as fine aggregate, not coarse aggregate. Because of the concrete work use the size of material to classify coarse and fine aggregates, not use the types of materials. Coarse aggregate. The coarse aggregate retaining on the sieve number 4 has the varied size starting from 4.75 to 37.5 millimeters, but the structure concrete typically use the maximum size not more than 19 millimeters. Because of the higher size aggregate, it's very difficult to place the concrete into the formwork, and the largest size aggregate will not pass the reinforcement steel, resulting the big void may be occurred in concrete structure. For fine aggregate, sand is generally considered to have the particle size between 0.07 to 4.75 millimeters, while that of material between 0.06 and 0.002 millimeters is classified as silt, and materials lower than 0.002 millimeters is called clay. Silt and clay are not suitable to use in concrete mixture because of the finer materials require water requirement in the concrete mixture in order to achieve the desired workability. In addition, clay will coat the aggregates particles and reduce the bond between aggregates and cement matrix, resulting in reducing the compressive strength of concrete. So the suitable size of the fine aggregate should not be lower than 0.07 millimeters. Basic properties of aggregates. Particle shape of aggregates. The particle shape and surface texture of aggregate has influenced the properties of fresh and hardened concrete. Generally, aggregate shape is divided into 3 groups. The first group is rounded, the second group is irregular or angular, the last group is flaky and elongated particles. This picture shows the rounded particle. It is completely water-worn and fully shaped by attrition. The good example of this aggregate shape is gravel, while the irregular shape, it is partly rounded edges, and angular shape has sharp corners or little evidence of wear. For the flaky and elongated shape, they are undesirable in concrete mixture because they have much negative effect on the concrete properties such as workability and compressive strength. The flaky particles can crack very easily, which can lead to weak in concrete strength, while the elongated particles resulting in increased the friction between the particles, hence reduce the workability of concrete. This slide shows the definition or criteria to classify aggregate as flaky and elongated particles. A particle is flaky if its thickness, least dimension, is less than 0.6 times of the mean safe size. For the elongated, it has the length of particle more than 1.8 times of the mean safe size. Generally, the elongated or flaky particles should not more than 15% of the weight of coarse aggregate. Fineness and gradation of aggregates. The fineness index of aggregates is typically measured by using the value of fineness modulus or FM. This value is obtained the testing of sieve analysis in laboratory. So you can find the video clip of this testing at the end of the handout. The FM value of the aggregate can indicate the size of the aggregate. The value of the fineness modulus is higher, the coarser is the aggregate. The size of aggregate has directly affected on the properties of concrete, especially in workability of concrete. It is noted that the lower aggregate size, the overall surface area of the aggregate is higher. From this picture, if assume this box is the particle of the aggregates, the bigger box has the lower area, which is obtained from only 6 outer sides, while that of the smaller box has higher surface R, which is included the inner area of the cut box. That's why the smaller size of aggregate has more area to absorb the water, resulting increase the water requirement in concrete mixture. It is well known from the previous chapter that the compressive strength of the concrete is decreased with the increase of the water to cement ratio. In case to control the water content in concrete mixture, the mix is very dry and very difficult to place the concrete into formwork and need more energy to compact in order to obtain good concrete. For the grading of aggregate, grading is the particle size distribution of an aggregate as determined by a sieve analysis, which is the same testing of fineness modulus. Gradation of aggregate affect relative aggregate portions, as well as cement and water content in concrete mixture. In addition, variations in grading of the aggregate can seriously affect the uniformity of concrete. The picture shows the grading graph of the coarse aggregate. X direction is the size of the aggregate in log scale, and Y direction is the percentage by weight of the aggregate passing each sieve size. From this graph, the green line represents the well grade of the aggregate, which is characterized by the S-shape in gradation curve. This line contains various sizes of the aggregate starting from the finest to the coarsest. The blue line is poor graded aggregate, which is small variation in size. It contains aggregate particles that are almost of the same size or single size. This means that when the particle packed together, it has large void in the concrete. Sometimes this gradation is called uniform graded or single size grade, and the gradation curve is very steep. The last line is red line. This curve is called gap graded aggregate. It consists of the aggregate particles in which some size particles are missing. It is characterized by a gradation curve with a hump in between, or the curve is flat in the mid-size range of the graph. The good example shown in this picture in the red box, it has only the bigger size and the smaller size, the mid-size is missing. So what is the effects of gradation on the concrete mixture? These pictures show the effects of gradation of aggregate on the paste volume in concrete mixture. If assume the box having gray color is the volume of cement paste in 1 unit volume of concrete. It should be noted that the single size gradation, which is the poor gradation, requires more cement paste as compared with others, resulting in higher cost and volume change in concrete. For the well gradation, it requires the lowest of cement paste volume. The last topic is specific gravity and absorption of aggregate. In this topic has two keywords. The first keyword is specific gravity, and the second keyword is absorption. It is well known that specific gravity is the ratio of the weight of material to the weight of water having the same volume of such material. It has three different types of specific gravity, but in concrete work, use only specific gravity at saturated surface dry condition. For absorption, it is an ability of the aggregate that can absorb the water into its particle. Generally, the aggregate particle has two types of void, permeable void and impermeable void. Permeable void is the void that allows the water penetrate and fill the void, while that of impermeable void is the void don't allow water to penetrate, which is mostly internal void or very small void in the aggregate. So saturated surface dry condition is defined as the condition of the aggregate in which the surface of the particles are dry, but the permeable voids are saturated with the water. This condition is an ideal condition of the aggregate and very useful to calculate the mixed proportion of the concrete. Saturated surface dry or called as SD is the aggregate does not absorb and contribute the water in the concrete mixture. I give you an example. Today is raining. The aggregate is in wet condition. Next day, the weather is very hot and dry. The aggregate is in dry condition. So, if you prepare both aggregates at the same weight for mixing concrete, the water or moisture content in the aggregate is very different. The concrete made from wet aggregate has very high slump or maybe too wet, while that of concrete made from dry aggregate has very low slump or zero slump. Although both concrete mixtures have the same aggregate portion, but much different in workability of the concrete and do not control the concrete quality. This picture shows four conditions of aggregate. It is starting from the often dry condition or no zero moisture content in aggregate. Next is air dry condition or some part of void filled with the water. Next is SD condition. And the last one is wet condition or the moisture content in aggregate is more than SSD and it contains excess of water on aggregate surface. So if you know the moisture content and the water absorption of aggregate in SSD condition, which is the baseline, you can adjust the content of the mixing water in concrete mixture in order to obtain the same workability. The absorption of aggregate can be calculated from this equation. It is the difference in the weight of aggregate at different conditions relatively compared with the oven dry condition in unit of percentage. Typically, the moisture content at SSD is called absorption, while that of any point is called moisture or water content. It should be noted that if the moisture content is more than absorption, aggregate is in wet condition. Conversely, if the moisture content is lower than absorption, aggregate is in dry condition. As I mentioned you earlier, absorption of aggregate is very important for calculating mixed proportion of concrete mixture. From this picture, if aggregate is wet or moisture content more than SSD, calculate the difference of water content and how much the excess water in aggregate as compared with SSD condition, resulting in reducing the total content of the mixing water. If aggregate is dry condition, add the mixing water to compensate the absorption due to dry aggregate. So the obtained concrete mixture after being adjusted, the water absorption will have the same workability and we can control the concrete quality even though the aggregate condition is varied. At the end of this section, I hope that you will see the importance of aggregate, which is one of the main material for producing concrete, and will have more understanding about concrete in order to use this knowledge in the next topic. design of mixed proportion of concrete. For more information about the test methods and procedures for determining the density of cement, the specific gravity and absorption of aggregates, and the sieve analysis of aggregates, you can download the details using the provided QR code. Thank you and see you next time.